Hi everybody, and welcome back to CAD1134. This is week 8 of 14, so we are definitely getting on. We're past the halfway mark, and hopefully you are feeling comfortable with working in 3D at this point, and that you can appreciate how working in 3D can actually help your 2D out, mainly because you can't make a 3D drawing without first being able to draw in 2D. Today we're going to be reviewing some print reading and layouts. We're going to talk about dimensioning. We're going to be talking about creating some geometry, some tricks and techniques for that. We're going to be looking at moving, rotating in 3D. We're going to revisit importing and inserting, but the big thing this week is the align tool. And so we're actually going to take some 3D objects that we have and align them together. We're also going to talk about a new command called WBLOCK or right block. Attaching and clipping, there's some information around, but we're going to probably not worry about that too much today. But I do want to talk to you about first and third angle projection and how to set it up on your drawings. The first thing that I want to talk to you about is about print reading and layouts. If you recall from one of the first weeks that we were here, we talked about how prints and drawings are a form of communication. And so, like most languages, there are hard, fast rules that we must follow, and then there's guidelines that we should follow. It's the same with drawings. There are things that we are allowed to do and not allowed to do. And then there are good practices that we follow. Now, one of the things that we see here is that we try not to have extra drawings that don't show any information. And so you can see from these three views that are in wireframe that there are dimensions associated with all three drawings, and that there aren't any repeat dimensions on any of these drawings. For example, even though the 5mm wall thickness is replicated in two places, it's actually dimensioning the two different walls that make that L bracket. The same with the holes. Now, stating that the holes are 3.97mm on both of them could have been avoided by adding a note that says 5 places. But in this case, they are actually two different drawings, and so we can actually get away with having that same dimension in two places. Even the isometric view, the shaded view, it's there for a purpose, and that is to help the viewer, the reader, understand what's going on. The other thing is that we need to understand that this drawing is laid out in a fashion that is a standard. And for example, you'll notice that this edge is this edge. This face here, this edge becomes this face. Okay? And the same here. This edge becomes this face. And so we're actually taking this part, if you would, we're looking at it like so, and we're taking it and rotating it around like so. Okay, so how these parts are laid out is absolutely critical. And when we were talking about first making drawings, we were also very aware that this edge and this edge must align. You don't want to see this drawing over here and this one down here and this one up here. They are as if we took the part and rotated it around. Okay. Now, the next thing is about creating geometry. as we start to make more and more complicated geometry, keep in mind that most of the time it's made up of very basic shapes. Okay, for example, all of this detail for the vents in this cover that are kind of the Durham College logo. If we break it all down, it's not actually that complicated. Okay, we have a rectangle with some fillets. We have another rectangle with a big fillet on the side. And what I did here was I actually used the array tool to take those and array them around. You can think of this like building blocks, as if you had Lego brand or Duplo or whoever blocks, and you're assembling these very simple pieces to make a very large and complicated structure. You shouldn't, however, rush putting your parts together. Okay, for example, the vent holes that I put in here, I changed many times. I didn't know if I wanted 6 or 5 or 4. I didn't know where exactly I wanted them. And so I played around with it until I got it exactly the way I wanted it. And then I used the Boolean operation to do the subtract. The same with the addition of this cord grip that's in here. You want to make sure that it is where you want it before you finally press enter. Now, that said, it's always a good practice to do your revisioning. So keep a log. Okay, every hour or so, save the file with a new name so that you can go back. For example, I've done some Boolean operations and it's all turned into a disaster. How do I go back? Well, you can only use Control Z so many times, and then you run out of undos. So if you can go back to what you had an hour ago or a day ago, it's fantastic, and you only lose that much work. That said, you shouldn't be worried about remaking a part, especially now when they're very simple parts or simple assemblies, that if you completely mess it up, it should only take you a fraction of the time to redo it. And that's often faster, easier, and better than trying to bodge a solution. To prevent needing to do this in the first place, you should be planning several steps in advance. That means sometimes adding parts or features before certain functions makes sense. A great example of this was one that we showed you at the beginning of the introduction to 3D, where we added a fillet to the cube before we use the shell command. If I do it afterwards, I have to do the fillet command twice, once on the inside, once on the outside, and the opportunity to make a mistake is absolutely there. Okay, so as far as the review, some commands that you should absolutely be aware of and familiar with are move, rotate, and rotate 3D, insert, and import. If you're not comfortable with these, I recommend you go back to the previous week and get a little bit of practice, because you're going to need it for this week's assignment. Okay, so what is WBLOCK? WBLOCK is the same as the block command, but instead of it storing the drawing or the block inside your drawing, it will export it to its own little drawing. This is super useful when you have more complicated shapes than, say, a simple drawing of a diode, but it's something that you're going to want to use over and over again. And so by using the WBLOCK and giving it a file name, you'll be able to save it to a library, which would be a directory available on your computer, and you'll be able to import it or insert it anytime that you need it. If you imagine a more complicated part other than a simple 2D wireframe, having several components that you brought in every time, for example, socket head cap screws, every variation of every size would be a huge, huge overhead. And so you only want to bring in the screw that you want and the washer that you want and the nut that you want. And then you can assemble them in 3D space. All right. The next thing is I want you to open up the starter file that you will find on DC Connect, and I want you to rotate it around so that it looks similar to the view that I have here. Okay. So now that we have our file open, what I want to do is I want to use the align function to move this block over to here. And so I will use align. I'll choose the block or blocks that I want, in this case just the one. I'll press enter, and I will choose my source point being the center of the circle and my destination point again being the center of the circle, and I'll press enter. And you'll notice it lines up perfectly. Okay. So I'll just Control Z here, and I'll move it back, and I'll do this again, but this time I'll use block number 2. And so I will align that point to this point, and I'll press enter. And you can see this time it didn't work nearly as well, right? The red circle definitely lined up with the red circle, but the magenta and the green don't align. And the reason being is that we asked it to align a point to a point, and that's it. So it did exactly what we asked it to do. So this time I'll use the align command again. I'll choose block number 2. This time I'll pick the red circle to the red circle and the magenta circle to the magenta circle, and I'll press enter. And it asks us, do we want to scale the object based on these points? Today it wouldn't make a difference because they're exactly the same, but if those 2 points were different, it would actually take that and stretch it out. And so the difference here is we've said I have a point, and then we're defining the second 2 points as either a line, okay, where it would scale it, or a ray. And the difference between a line and a ray is a ray goes infinitely long. And so by saying don't scale it, we're telling AutoCAD that this isn't a line, that we have a point and a ray. So it's going to align not just the point, but create an axis. Okay, so I'll say no. And so this time it does actually work out. It lines it up perfectly. If, however, I use the align function and on block number 3, okay, align. So source, destination, source, destination, and press enter. You'll notice that it does actually line up the 2 points, or the point and the axis, but the third one is way out. So that doesn't work this time. What we need to do is align again, but this time we'll choose the source, the destination, the source, the destination, and the third source and destination. And we don't even have to press enter because the 3 points makes up the perfect piece of geometry. And so what are the 3 points to make the perfect geometry? We have a point in space that fixes, so our 0, 0, 0, if you would, an axis, okay, that creates a line, and the third one creates a plane. And so if I have a line and a plane and a point, I am absolutely fixed in all the dimensions. Okay, so here I'll undo it again. If I try to do block number 4 like this, though, it gets very difficult to pick the points. And so, today we could get away with rotating it around so that I can see all 4 points. But perhaps there was something else going on that I couldn't readily do that. And so if I'm zoomed in here, you'll notice that I can't really see my destination points. All I can see are my source points. And so the other command that we can use is the 3D align. Okay. And how does 3D align differ? Mostly that you'll pick your 3 source points first. And you'll see AutoCAD's actually telling us what to do. So specify a source point would be the center. And it's really important that you remember the order in which you pick these. So the red is going to be my point, the magenta creates the axis, and the green creates a plane. And you'll notice that I can kind of drag the part around with me. And so in this case, because I have something nice and visible, okay, like that red circle, I can line up the red circle to the red circle. And now it's trying to get the purple or the magenta to line up. And so here we go, magenta to magenta. And then finally, I can bring the circle around for the green till it lines up on the center point as well. And insta presto, we have a perfectly aligned part. If your part ends up inside out, upside down, backwards, then you know that you've picked the order incorrectly. Okay, so for example, here we go. I'll do this again. So 3D align. Pick this guy, and again, red, magenta, green. And this time I do green, red, magenta. You'll see that the green and the red points match. The line that I created between the red and the magenta matches with the red and the green that I selected. And the faces, right, the triangle that it makes lines up. And so it's done exactly what I've asked it to do, which is completely wrong. So that's okay. Just be aware that that's the situation. Okay, so as promised, we are going to talk a little bit about first versus third angle projection. What is first and third angle projection? Well, first angle projection is the ISO standard. Third angle projection is the imperial. It's what we see quite a bit from anything in North America, but the rest of the world tends to do first angle projection. And so if you look at the symbols here, we actually have an illustration. And if we look at the right-hand side, you can see the big circle and the little circle. And when we rotate it around here, or tip it over, the small circle is on the left-hand side and the big circle is on the right-hand side. So first angle projection is like taking something and just tipping it over, okay? Whereas third angle projection, in order to make it work, we actually have to flip it over, okay? So, and we're able to see that here, where if we take the two circles, in order to make it fit over here, we'd have to take it and rotate it. All right. So how do we get there? What we need to do is you need to go to your Layout tab, and under Styles and Standards, there's a little pull down here for your manager, and you want to choose whether it's first or third angle projection. It is good practice to always give this symbol on your drawing somewhere so that people will understand without thinking about it that this is first or third angle. This becomes really important so that you don't end up with your parts made backwards. It's happened to me in the past. We were actually very far along in a project when we realized that the part was inside out. And that has to do with wonderful wireframe drawings before we had 3D CAD. And here's an example where we can take a part. It's my favorite piece of geometry for demonstrating CAD like this. And you can see here in third angle projection, the line that makes the top of the fillet here, the chamfer, is on the bottom. So we've taken this and we've flipped it down. Whereas when we look at the first angle projection, this line ends up on the top. So we've tipped it over. We're not going to worry about thread styles. We're absolutely not going there. But being able to change back and forth is something that you'll need to do. Be aware, though, that in the middle of a drawing, you can change. And that's how I managed to create this drawing, was to create the first layout in third angle projection, change over and make the second one in first angle projection. If you change halfway through a layout, it will create a lot of trouble. Okay. So be aware, be careful. All right. Now, the next thing is for your in-class exercise, I would like you to play around with my little puzzle that is in that file. Try to assemble it. Do your best. It's meant to be fun and educational. They do all fit. Trust me. I know they fit because I made the block from these parts, so they absolutely fit. And it's good. It's good practice to get into the mindset of manipulating these parts. Some of them will be able to be placed with a single point, some with two, and some with three. So I want you to play around with it and really get comfortable. For this week's homework assignment, we have another fairly hefty bit of kit to make. This time I want you to import this box. This is 1591 XXESF and BK for black. If you don't end up with the black one, that's okay. I also want you to import this New Haven display here, the 0216MW. I also want the HG-315, which is a grommet. You're going to have trouble finding this keypad. That's somewhat intentional. The idea is that I want you to create a keypad as a placeholder. So what's a placeholder? It is a piece of geometry, a piece of CAD that is not intended to be an exact replica, but to have the critical dimensions required. For example, the outside perimeter and the mounting holes are required. You may also want the thickness. You can get fancy. You can put some numbers on it. You could skin it. There's a lot of things you could do, but none of it's really required past the mounting holes and the absolute geometric bounding. Okay. Once you import these parts, I want you to obviously move them to their own layers. Make sure that they're properly formatted. And then I want you to modify the box to fit the display and the keypad and the grommet And I also want you to create a PCB. Okay, it can be anything you want, any size you want, but it should mount into the box and assemble it all in 3D. I then want you to create some drawings from it and do your best, okay? I'm not really expecting perfection. We're going to get into that perfection bit in the coming weeks, but do your best. I do expect it assembled fairly well, but if you're having a little bit of trouble, it's not the end of the world, okay? My marking is based on this is the first time you've really done this. All right. This is a 2-week assignment. The reason it's a 2-week assignment is next week is test number 2. Test number 2 is like test number 1, where we're going to have a quiz, and then I want you to draw something. The drawing in this case is not overly complicated, but it is going to involve importing something and manipulating it. So the best way to study for this test is to actually do your homework assignment. So get started on it and be ready for next week. All right. I know that this is a very complicated project. It's a lot of work, and it's difficult for a lot of people to get their head wrapped around exactly how to do this, and that's kind of on purpose. It's supposed to be a challenge. Hopefully you rise to the challenge and can excel. If you're having any trouble, any difficulty, please send me an email right away. It's best to find out about these shortfalls as soon as possible so that you can get the help necessary. And if you're struggling, perhaps other people are, and I can create an update video to help out. All right. So again, understanding this is a complicated project, and I'm not really expecting perfection this week. Do your best and try to have fun with it. All right. Thanks. Have a good day and good luck, everybody. Bye now.